Scenario: a vinyl has a rotational inertia of 2.0 kilograms times meter squared, spins counterclockwise on an axle with an initial angular velocity of 5 rads per second. An average counterclockwise torque of 4 Newton meter is applied for the duration of the 6 seconds on that vinyl. Question: correct the following statement on this scenario. Annabella says, since the initial angular velocity was going counterclockwise and the torque was also going counterclockwise as well, there is no change in the angular momentum of the vinyl records because the torque was in the same direction as the angular velocity. Here's the answer. Well, there is still a change in the angular momentum because even if the torque is applied in the same direction as the angular velocity, because the equation is defined as delta L, which is the angular impulse, is defined by torque times the change in time. There is a torque and there is a time value for that. So there has to be a change in angular momentum or angular impulse. The next question asks you to actually calculate that value. So we can substitute the values in here. 4 goes in for the torque, 6 goes in for the seconds, and the unit would be kilograms per meter squared over seconds. So here, the change in the angular momentum is 24 that unit. This being a positive value indicates that it's going to increase the speed or velocity of the rotating vinyl. So it's not going to slow down anytime soon. It's just only going to speed up because, again, the torque that came in helped it because it was in that direction. So the change in angular momentum can either help by speeding it or hurt by slowing it down, but it still always occurs.